Good morning, good afternoon, or good evening, and welcome to this Techstrong learning experience brought to you by Security Boulevard. My name is Cody, and we have an exciting presentation ahead. Before we begin, I do have to cover just a couple of our housekeeping notes. Today's session is being recorded, so if you miss any of our discussion, perhaps you'd like to rewatch or maybe share with a friend. The on-demand recording will be made available shortly after we conclude our live session. If you look to the right side of your screen, you'll notice there are a couple of options for you to engage with our panel today. First of which is the chat tab, so go ahead and start warming that up for us right now by letting us know from where you are joining us. If you have any questions for our speakers, I will direct you to the Q&A tab, which is directly to the right of that chat tab. And of course, before we close out, we are going to be giving away 4 $25 Amazon gift cards, so be sure to stick around for the duration of our program today. Our topic today is software supply chain security, and I'm joined today by Matt Rose, Field CISO at Reversing Labs, Mike Rothman, Chief Strategy Officer at Techstrong Group and GM of Techstrong Research, and leading our conversation today is our very own Mike Vizard, Chief Content Officer at Techstrong Group. So Matt, Mike, and Mike, thank you all so much for joining me today. Mr. Vizard, would you like to take it from here?
Thank you, Cody. Matt, let's start with you. I'm trying to get a handle on just how big an issue we're really looking at these days. We are building software faster than ever. We have a lot of software that's deployed, and we have a certain sense of these vulnerabilities that are in that, but it's not clear how critical all those vulnerabilities are. And we don't have a real sense of, is this a major crisis that has resulted from all the technical debt that we try to manage, or is this something that is manageable today, but we need to just be aware of it and more cognizant of what we're doing? What's your sense of where are we on the curve of intensity, as it were?
Yeah, the thing that I think the industry really is struggling with still is the definition of, supply chain security or software supply chain security, where everybody says they do it. It's the latest, greatest, coolest thing to say that you are a supply chain security vendor. And it's really nebulous in terms of its definition. And the thing that I think that the problem is until we can truly define what software supply chain security is, it's going to be an ongoing problem. And I like to kind of bucket it into the four main areas of the way people are trying to address it. Is the legacy AppSec tooling saying, hey, we do supply chain security too, or software composition analysis saying, hey, we're software supply chain security for SBOMs and open source packages. But again, that's just piece of the application. Then you have supply chain around like firmware and IoT and that type of space where software supply chain is kind of melded into that space. And then finally, you have the tooling vendors that are basically like, we're going to make sure that assembly line is completely secure, from the IDEs, IDE plugins, code repos, CI orchestration, continuous delivery environments. So you got a lot of different things moving out there. And I really think that the problem with that is that's not really supply chain security. That's supply link security. You have different pods of things you're doing to ensure security of the supply chain, but it's not the complete chain or all aspects, because if you mess up in one of those areas, you're going to have issues. And as you said, speed kills, and the speed of modern CI/CD processes is getting faster and faster. And there's truly not one person that understands the complete architecture of an application in organizations. So you get all these things moving at the speed of light, and nobody truly knows the answer. And until we define what software supply chain security is, we're going to struggle.
Mike, what's your sense of this situation as we find ourselves in today?
I want to address the technical debt piece of things a little bit. I think, Matt, you did a great job really, kind of hitting on a lot of the issues that we have relative to supply chain. But being an older guy who's done security for a long, long time, right? Application security, or the lack of focus on application security, was always something that kind of made me shake my head. It's just like, this is where our code is, right? This is the intellectual property of most, certainly software driven, and what organization is not software driven nowadays. So it just never made sense to me that we weren't spending a lot more time and a lot more effort on making sure that we had robust and secure software that we were, kind of rolling out. So to your question, Mike, I think we have significant debt on the part of application security. I think we have process issues that we've never addressed. And there are things like DevSecOps, which I know we're going to talk about quite a bit, and other, kind of organizational, evolution that are looking to try to address these things. But we've got just decades of code that we haven't paid any attention to from an application security standpoint. We're opening up a lot of these things, to customers and to the internet. And as we keep seeing, I mean, it tends to end badly. Maybe not as badly as we think it should, right? Because, folks make the mistake of asking me like, well, should I do this? Or, is it secure to do that? And I'm like, don't ask me that question. They're like, well, why shouldn't I ask you that question? Because you don't want to know, right? Because if you knew what we know, right, we wouldn't get out of bed in the morning, right? At some point, you just got to be like, I'm going to take that specific risk with my personal data. But I don't think this is a problem that goes away. I think this is a problem that over time, because we're constantly cycling some of these applications and they're getting, kind of decommissioned, it kind of works itself out. But we're at a point now where there's so much debt. I don't know that we can really address that, kind of logically and feasibly, in any kind of reasonable planning horizon.
Yeah, Mike, that tech debt, it's an interesting concept too, because we have this tech debt of known type of issues, but what about the unknown issues? And software supply chain is really about, malware inserted in some way, shape, and form. So everyone's struggling to find known vulnerabilities, but it's that unknown that is the problem. So how do you address the unknown issue when you have this tech debt of, hundreds, if not thousands of known issues? And the one that keeps, been doing this a long time, it's still struggling to find SQL injection and cross-site scripting. I mean, I've been doing this 20 years and we're still having that problem. And now we basically have made this very complicated build process, CI/CD at speed, that are basically introducing unknowns that you don't even know how to look for or address until they happen.
Well, and I don't think we do. I think we wait for them to become knowns and then we deal with them. Right. So I don't know that and nobody that I know is like, hey, let's go looking for unknowns. I mean, I guess if you're hunting and you kind of are proactively able to go after and build a hypothesis and try to, test it in your environment, you've got a chance to pick some of these things up. But the reality is most folks continue to be very reactive. And every, 6 months or 8 months, we kind of go through this marketing cycle where folks start talking about being proactive again. Right. I kind of, sit in my chair and kind of sit back and chuckle and go, ha, 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 ha. Oh, we're talking about being proactive again. Ha, ha, ha. That'll last for a month and then we'll go back to, oh, crap. We got to figure out what's already in the bucket. Right. So I think that's cool.
Well, and I think that a lot of these breaches that happen that we, the things that we talk about, they just have such a short shelf life of attention. It makes for kind of the same story and over again. It could be, think about SolarWinds or Log4j or Spring Shell or insert major breach or hack here, and everyone freaks out about that, and it's really complicated. But then they're like, oh well, we took care of it, so let's move on, and they forget about it, and then the next one comes, and everybody freaks out, and without proper processes to identify early, remediate fast, we're going to be just stuck in the mud forever and ever and ever. Because again, I always say that major breaches have 10 seconds of fame and then they go the way of the dodo.
Right. So for the last 3 decades, somebody has always said, this event will happen and this is going to be the wake-up call for security, and then everybody rolls over and hits the snooze button and goes back to business as usual. But there is a change in the air where people are talking about DevSecOps and the need to shift responsibility further left towards developers. But how real is that, Matt? Because most of the developers I know never took a security class in their life. It was an elective at best, and nobody made them take it. So, and a lot of people aren't even, trained developers in some school. They just came to the business naturally with some gift. What is real about the ability to shift security left in the context of a software supply chain security program?
Well, a lot of people aren't going to like what I have to say here because I've been saying this for a couple of years now. I think shift left is a term that is dated and no longer applicable to modern software. The reason you think about DevOps, you said DevSecOps, and then you say shift left. If you see the representation of what DevSecOps looks like in the infinity loop, and something is happening at every step within that infinity loop, instead of it being a linear process where you design, code, test, develop, release, you're constantly releasing, something's always happening. So where is the left? And truly, with modern processes like cloud native development, there is no left. It's basically just, a branch of the main trunk of the software development process that then rejoins, and team A only does their responsibilities, team B does something else, team C does something else. And I think that if you approach, security as a shift left mantra, you're only going to find vulnerabilities on the left. You need to shift security everywhere. You need to shift it at the developer's desktop, within the code repos, within the CI orchestration, within the deployment, within looking at the deployable package itself. Because if you're only looking on the left, you're going to be wide open to a litany of risks that you're not even looking for. And I hope that the industry can get rid of shift left, because I feel like it's no longer applicable to modern software or application development processes. Mike, your thoughts?
Oh, I'm totally with you, right? So it feels like a long time ago, but in early January we did our Predict 23 conference, where we talk about a number of trends that we put together at Techstrong Research, and we had a nice panel of folks that come from both the development side and the practitioner side, and the CISO. We had a CISO on the panel too, and I think everybody kind of was in consensus that shift everywhere is definitely a better kind of philosophy in terms of there. I mean, clearly you're seeing developers push back on, hey guys, I gotta ship code. Now you're dumping all this security crap in my lap, and I don't, understand it. I'm not trained to do it. I just, so that kind of, we started to see that pushback a little bit last year. But as you said, right, I mean, it's not as simple as just saying, well, hey, if the developers would, kind of write secure code, then we wouldn't have any other issues. I mean, you got issues in again, supply chain, right? That's what we're here to talk about. So you're integrating all of these different code bases in there that could be vulnerable from that standpoint. You've got deployment, and then you've got customers that go in and find logic flaws in your environment that, again, you're not going to pick up with a scanner. So it's not something that you can set and forget. It's not something you can dump off in somebody else's lap. I mean, I think it really is something where you have to have security kind of integrated into all of those different aspects around the curve, and have incentives for folks to really play along with security, right? Or at least ask the right questions. And we don't even see that, where, folks know everything in security. Again, it tends to be adversarial. And I mean, that feels like, 1998 calling, when you talk about, security being adversarial with everybody else. But we still see a lot of that, sadly enough, right? And until we kind of build those relationships and have an environment where we can be mutually productive and understand that we're all pulling in the same direction, it's again, we're not going to really make a lot of progress.
Yeah, and I like to kind of, Mike, before we go on, just one thought on this. I like to kind of give evidence to support this. Thinking about supply chain security, and let's use malware insertion. And if you're shifting on the left security practices, okay, you're only going to find a nefarious developer do something on purpose or by accident in terms of inserting malware within their IDE as they're writing code. Then as you move through the process, you're talking about the code repo. Oh, did somebody compromise the code repo? Was malware inserted there within the process? Oh, what about the open source repository? What about the binary repository? What about a hack of a major tooling component of your DevOps process, like the Circle CI breach or the Circle CI hack? What about the deployment process? So there's opportunity for malware to be inserted at every step in that process. And if you only look on the left, you're only going to identify, maybe, if you know where to look, the potential of introduction of malware into your software application. But there's tons of other areas that need to be investigated for that same exact problem. And that just, proves that shift left it should be, no longer used as an applicable approach.
Yeah, I've heard a couple of developers more than once say, if you just take that F out of that first word in shift, you'll know exactly what's going on. So, Mike, let me ask you a question then. All right, we still got to solve the problem. So where do the cybersecurity people fit in that process for application development? Are we seeing more security people become savvy enough to have that conversation with developers?
Yeah, I mean, so the reality is not all of the developers are going to understand and really have a great level of understanding of security issues, but some of them have to, right? We can't just rely on the security folks. There just aren't enough of them to, in effect, be lent to each one of the development teams that are there. So I'll give you a real example. I'm working with a client on an assessment, maybe 2-3 months ago. These folks had 240 agile teams that were out building code, doing, kind of different things in different sprints. They had 12 security architects, and they were trying to figure out how to, kind of provide some measure of oversight and even advice in terms of the changes that were happening in each one of these teams. The numbers just don't work, right? The numbers don't work from that standpoint. So we have to figure out a way to, in effect, deputize some of the developers so that they can become the eyes and the ears and the subject matter expert on security. Some folks call that security champions, and I do kind of like that concept and that term. Provide some incentives for those folks to go to training and really understand about security, but more importantly, to become the resource on the development team so that you can at least have some sense. And again, there's going to be stuff that's going to be over their head. There's going to be stuff that you're going to have to bring, kind of those security architects in order to really understand what should be done. But the day-to-day stuff that, your typical junior developer just isn't going to understand, I think that does need to be addressed down at the development team level. And that's going to require an investment in terms of getting, at least 1 or 2 of these folks on each team, trained up in terms of basic, kind of security hygiene and development practices.
Well, Matt, let me ask you a follow-up question to that, because one of the things you do hear from developers is like they will complain that they're writing code on this day, and then they'll do the build, and then somewhere 3 weeks to a month later, somebody on the security team says they discovered an issue, and the developer has no idea. They're not in the moment. They're kind of like they have to go back to whatever they were doing back then. They got to drop the task. So how do we do this in a way that maybe, to Mike's point, if we want to kind of coach people and alert them, is there some way to provide more context when they're actually writing the code that says, hey, this thing that you just created is going to lead to a SQL injection attack. Just, danger, Will Robinson, you might want to fix this.
Well, I'll even add some more, fuel to the fire there. What about if the developer that wrote that piece of code is no longer with the company? Which, happens all the time, where it's like, Joe wrote this. What the heck was he doing here? I don't even understand. I think one of the things too, if you think about it, going back in the context of, security issues, whether it's a vulnerability that's in the OWASP top 10 realm, or, something that is questionable in terms of behaviors and malware trying to cover itself, is that, especially in cloud native development, you don't have the whole story as the developer. You never have the whole story. And for a lot of these issues to kind of propagate themselves, you need the entry point, the execution point, all the steps in between, validation. And if you don't have that in a developer world, you're never going to know what the risk is. You're just basically responsible for the front end or the database tier or the business logic tier. So it is very complicated to use the software application security technologies to find these type of vulnerabilities. And everyone's trying to change the way they're architected, but they're basically kind of trying to pivot, real time to basically address the entity that is the way software is developed today. And that's the biggest thing, is all of these application security tooling technologies are designed to help with the modern process. And, we've changed from waterfall and releases every 3 months to releases every 3 minutes. So the tools have to keep up. And that's why the new type of technologies have really been introduced, such as, we started with software composition analysis, and now API security, and, environments for IAST, and, modernization of SaaS tools. So from a developer standpoint, I think it's really irresponsible for organizations to put all the pressure on the developers to write secure code all the time. Because that goes back to that mantra of shift left, where developers, you better do it right or you're in a heap of trouble. I think it has to be a testing of the process as it moves through, and security really has to play a bigger role to understand, okay, this is how the software is architected, this is how it's put together, and these are the things I need to look for. Because I think you're doing the developers a disservice by blaming them for all the vulnerabilities in code, because they just don't know, or they don't have the entire code base. Mike, do you feel the same way with that stuff, or?
Yeah, well, Mike, to follow up on that, we just saw the National Cybersecurity Strategy document came out, and if you bury deep into that thing, you will find there are references to we're going to hold application developers liable for things. So do you think that that is helpful, or do you think that just puts more pressure on a system that's kind of flawed in the first place, and maybe we should fix the system before we, hold people into court and say, hey, guess what? You're going to be sued for $1 billion.
I've been waiting for software liability for a long time. I think I will continue to be waiting for software liability for a long time to come. My first inclination when you started the question, Mike, was, good luck with that. Right. And I mean, we have a hard enough time getting, kind of the search engines to be any, somewhat responsible for the, kind of content that ends up on their environment. That's a big, kind of political football. The idea that you're going to hold companies accountable and how do you determine who's actually at fault, given the complexity of the software supply chain now? I just don't think it's a tangible and feasible, type of position. I do think that it's important that companies understand that if there is gross negligence, right, that they can be held accountable. And it has to be gross negligence. I mean, it's not like, hey, somebody made an honest mistake, they integrated this thing. It's like you had someone in your midst and you knew they were disgruntled, or you knew, kind of they were doing something and you didn't do anything to, kind of stop it. That if it kind of hits the measure of gross negligence, then hell yeah, I want these folks to be held liable and responsible. But for day to day, every company in there, I mean, we don't have enough IRS agents in the US to get all the people who are blatantly cheating on their taxes, right? We're going to get you. We're all of a sudden going to show up with 40,000 assessors who understand application security and are going to be able to determine who's responsible for what. Now, to be clear, there are a number of good things in kind of the cybersecurity strategy, right? Secure by design, secure by default. A lot of the stuff that CISA is pushing is fantastic from a philosophical standpoint, right? To get all these organizations to understand where security fits into the process, that's great. I love that stuff. The idea that we're going to try to hold somebody accountable for something that, would fall into the category of, honest mistake, or something that, somebody malicious did on a component that I integrated into my environment. I don't see how that's really realistic.
Matt, what do you think? Some people would say that a SQL injection is gross negligence because we've known about it for a decade.
Well, I think it's like, the modern applications of pretty much every software company out there, and pretty much every company is a software company in some way, shape, and form, is that they truly don't know what their baby looks like. And I mean, you talk about gross negligence. I mean, the speed, and they're like, it works. Let's not touch it. Let's let it go. I don't care if there's dead code in there or potential backdoors or all this type of stuff. And I think that's where the kind of the dawn of the SBOM has really come about. But the problem with the dawn of the SBOM is, just like software supply chain security, it's very ill-defined. The executive order and the memorandum associated with that out of the executive office saying that, we highly, highly, highly suggest you provide us with an SBOM or self-attest. Well, what type of SBOM? We haven't even decided as an industry what is the standard format of an SBOM. And really, a lot of times people's mind immediately go to software composition analysis and their ability to produce an SBOM and the inheritance of all the open source components. And depending on what industry analyst you really follow, it's like open source packages make up somewhere between 40 and 80% of a modern software application. Okay, that's great. That's a huge, huge, huge metric of error in there. And then even if you say it's 80%, you still have 20% of other stuff. So the SBOM has to be comprehensive of everything that you're actually delivering in terms of an application or a piece of software. And I think until that's mandated in a format that's expected and clearly defined, we're still going to struggle with this, because, it's like self-attesting. Okay, my stuff's good. What are you going to say? My stuff's bad? I mean, that would be a death knell, and nobody's going to say my stuff's bad. And I think that standardization on that SBOM format and delivery mechanism is huge for just total transparency about what's happening.
You bet. But visibility is a good thing, right? I mean, Matt, we've been doing this a long time, right? And the first thing you always think about is visibility. I can't protect something if I don't know it's there. I can't, unless I have a view of the entire environment, it's really difficult to, try to attempt to protect things. So SBOM to me is visibility. Is it perfect? Of course not. Right? Is it actionable? It depends on what you do with it, right? But if there's a push so that you actually have to start documenting what's in your environment just to give you a sense of what's there, that's a positive thing, to move stuff forward. And how we action it, I don't know, right? How it actually kind of makes its way into, kind of different mechanisms, I don't know. We'll have to figure a lot of that stuff out. But the first thing is to get to a point where we have a requirement to know what the hell is going on. Right. And then once we know what's going on, then we can start to figure out how to make it better. But remember, it's not every company is a software company now. So it's not like we're just dealing with the Fortune 500. We're dealing with thousands or tens of thousands of companies who have developers who are doing things. So again, it's going to be a long process, but a lot of this stuff is positive. A lot of this stuff is, I think, a benefit to the general software development cycle. I just don't see how we really make it, kind of liable where there are real consequences besides market-based consequences where, you screw something up and, you're in a commodity business. Somebody's going to go get their garbage picked up by somebody else if you, kind of lose their data or what have you. The market tends to work a bunch of that stuff out over time. But again, with gross negligence and kidding aside about SQL injection and buffer overflows, I do think that we do have to make an example of someone because, that kind of starts to get folks thinking about, oh, wow, there actually are consequences to this thing. So Matt, to your point, you have folks that are making business decisions about availability versus, kind of protection of their customer data. And they're choosing availability every day of the week because there are very few consequences to, worrying about protecting your customers' data.
Well, I always say, plausible deniability is not a response anymore. I didn't know it was bad. Okay, maybe you just didn't want to look for the big scary monsters in the architecture or the code itself, and that used to be a defense. I didn't know, and I just think that we're way past that.
And back to my point of don't ask questions you don't want the answer to.
Or the corollary is, what do you mean that's not a deduction, right?
It was for business, I swear.
To that point, though, and Matt, are we asking too much of SBOMs, right? Because the initial thought process was, we just want a little visibility into where my log4j code is so I can go find it and kind of remediate it. And hopefully it's not publicly facing and I don't have as big a problem as it is. But it seems to have evolved in this conversation where, people want to operational SBOMs to the point where they can have a red light, green light before an application is deployed, and they want to try to automate all this stuff. And maybe that's a bridge too far. And maybe we just kind of have to think about, what is the purpose of the SBOM that is reasonable before we get down to some high level of automation where we're not deploying code because it has a version of a component with a known vulnerability in it.
Yeah, I disagree. I think we're already there. And I know of some technologies, hit me up on social if you want to know more, but I know of a way to give you that final exam of your package with a complete SBOM. And I think that is what we need. Because again, it not only helps you about finding, okay, new malware. Okay, is it in there? Yes or no? But it actually speeds the process of recovery of the next 0 day, of the next log4j. And the really pain of log4j was, it's about good packages going bad. Everybody used log4j because it was a known entity and it was popular, and all of a sudden it's no longer secure. It's no longer applicable to have in your code base. But it was so rampantly used that nobody knew where it existed, how many places existed. And there were tiger teams that spent 12, 14 hours a day looking for every instance to try and to mitigate the risk. I think having that complete SBOM as part of an ongoing process, I always say integrated and automated into the process, then the next, XYZ vulnerability 0 day like log4j comes out, you already have the data. If it's called foo or dog or cat, you can then go to see the historical information you have from the previous 100 builds and say, oh, here's where foo, dog, or cat are, and here's where we need to actually remediate them instead of starting from zero. And I think that's the thing, is we have to do a better job of being prepared for the next, issue, the next, oh my God moment, because a lot of times we're not. We basically go through the process. It's arduous. It costs us money. It's headaches. It's, people miss vacations and weekends and things like that. But then they don't put in the programs or the processes to prevent that same arduous task in the future. And that's where the SBOM, I think, really is going to help in software supply chain security is a must, because we got to be ready, willing, and able to address whatever comes out tomorrow, next week, next month.
And it's not like we haven't addressed or seen these kinds of issues before, right? EDR happened because we had a similar problem on the endpoint. Right? We had no idea what was on the endpoint. Something would go wrong and we wouldn't know where the libraries were. We wouldn't know if the thing proliferated. So we started gathering much more detailed telemetry from all these endpoints. We put it in a central place. And when something went down, we could do a quick search and go, oh, that's on 50 devices. Oh, crap, I got to go fix those right now. Right? Because that's where it proliferated. That's what it is. Same damn thing, right? We're talking about starting to get a better assembly or aggregation of what all these different components are across all of the software in the environment. We know something like Log4j, and again, I'm old enough to remember the JET database, which was the first damn thing. It was the same exact thing. It was a reporting thing. It was built into all the software that we use. Nobody ever heard of it until it was vulnerable, and they're like, oh my God, this JET database is everywhere. No kidding. Right? It was the easiest way to build reporting into any application, right? Or a quick database on that front. So we keep repeating the same stuff over and over again, but we can take lessons from other areas of security and apply them to this, right? Better telemetry, better visibility, better ability to search for things, faster time to react when something goes down, more effective response when we decide how we're going to fix the issue.
Matt, who's in charge of this? Because historically, this whole category is, the security people always thought that developers were somehow or other spending money to address these application security issues. And the application developers always thought the security people were spending money on this issue. And it turns out nobody was spending money on anything, because the security people were like, we're going to spend money on things we control. And they may not have the control over application security. So as part of the issue is just the way that we're currently organized, and we need to kind of sit down as organizations and figure out who's in charge of this.
Well, okay, I'll start with this question. It's like, who in the organization is going to ask the hard question when the next, major malware comes in? Who is the CEO, CTO, CISO, whoever that is? Who are they going to go to? They're probably going to go to the application security team and say, okay, how does this fit in your area of responsibility? Are we susceptible? Do we have the problem? And then there's actually the process of building the software, which is the DevOps architects or the site reliability engineers. So I think it's a hand-in-hand relationship, not between developers per se, because developers, in terms of software supply chain security, they're writing the code, and okay, they're part of the equation, but it's much more about the process of building the code and verifying that the code is green or red in terms of the release. So I think it's a symbiotic relationship between application security professionals, architects, site reliability engineers, and DevOps engineers. And I think that group of people is primarily the tip of the spear for software supply chain security.
Yeah, man.
Mike, you agree with that?
I can just see it now, right? We're all going to get by the campfire. We're going to get some marshmallows. We're going to sing Kumbaya, and everything's going to be, fantastic on that front. Kidding aside, I want to draw a distinction between accountability and responsibility. Right? At the end of the day, the CISO is going to be accountable when there are major application security failures in the environment. Are they responsible? I mean, debatable, maybe. I don't know. But we do have to make it clear that kind of somebody's going to get thrown under the bus. It's probably not the CTO. If it's really bad, maybe it is the CTO, but that's only after, the CISO's gotten dropped out of the vehicle, kind of 4 or 5 miles back on that front. So it is incumbent, and man, I agree with you 100%. Everybody has to get on the same page, but it's incumbent upon the security folks, right? That application security team, in order to build those relationships with the DevOps team, right with the SREs, with the platform engineers that are trying to really enumerate a lot of these best practices in code, right? With the development and agile teams that are building these new features, with the QA team that's testing these to make sure that those potential security issues are reflected within the testing harnesses as they're, kind of deployed for the automated testing that's a requirement when you really want to get to an agile, continuous, integration, continuous deployment type of environment. So we as security people have to get out of our cubes, right? We have to go build these relationships, because at the end of the day, when something goes south, hey, I didn't know about it, as you said before, Matt, right? That's no longer sufficient, right? We have to be proactive in this case and build those relationships and understand what's happening in that environment, and try to work with, these teams to ensure that they're at least considering security when they're weighing new features and other things to build into the sprints.
Matt, do you have any tips for accomplishing that? Because there's no love lost between developers and cybersecurity people on both sides. The developers have been end running security forever just to get their code approved and shipped. And the security people kind of view developers often as the root cause of all things that are evil. So how do we kind of put these guys together in a way that, will maybe bury the hatchet?
Yeah, I mean, I think to answer there, it's like if this webinar was around application security specifically, that's always going to be a contentious relationship. It's much better in some organizations than others, but that supply chain, question is a totally different thing, because again, developers are primarily not the source of supply chain risk. It's compromising the process itself, or an insertion into the database, or a compromise of the build itself, or getting into a compilation process before the package is actually signed, all those type of things. So the biggest thing is, if software supply chain solutions are not automated, integrated into an ongoing process and are fast, they're going to be a headache, because the last thing everybody wants is another list of 10,000 issues you got to look at. It has to be fast, it has to keep up with the speed, and it has to be effective in terms of identifying, the things that you're concerned about: malware, questionable behaviors, all those type of things. And I like to use I always use movie quotes in my videos and talks and things I do. Is if anybody's ever seen The Usual Suspects and Kaiser Sose, it's the greatest trick the devil ever pulled was to make the world he didn't exist. Well, the greatest trick that malware ever pulled was to make application security professionals think it didn't exist. It's in there, but it's hiding itself in ways that you don't even know to look for. And if you don't change your thinking and still use SAST or DAST or IAST or SCA, you're never going to find those malware issues or those questionable behaviors that lead you down the breadcrumb trail to the malware. So when you're talking supply chain security, you can't, immediately, go through the process you always go through. Yell at a developer, what the heck did you do? You didn't sanitize your data input, or pull the right data from the database. You have to change your mind for this new evolution or introduction of software supply chain risk to everybody. Mike, do you agree? Or
I do. I would add one thing that I do think helps from a process standpoint, and that's requiring not just signed but approved components before they're integrated into production level software, right? Dev is dev. They're going to do stuff and they're going to screw it up, and they need to, right? Because they're experimenting with other things. As we move towards that, if they find a library that they like, or they find a component that they want to integrate it in, there has to be a process to get that vetted and approved and put into the repository so that it can be deployed into production reliably and securely. If you don't have that, it's just like in the old days of the application, the mobile app libraries, right, or the mobile app stores. Folks would pull something down, and shockingly enough, it had a whole mess of malware in it. It was just like, well, nobody ever asked, right? Should I do this? What is the risk of that? What data are they trying to do? So having that step in, and to be clear, it does take time in order to vet these things out and make sure that they're safe for production deployment. And to me, that's time I have to spend. Right? It's an investment I have to make, because if I'm taking crap components that could potentially be vulnerable and I'm integrating that into production software, bad things are going to happen. Now, to your point about Log4j was fine until it wasn't, Once these things are approved, they get into my SCA harness so that I'm monitoring, kind of each of these packages for potential issues. I'm flagging them, I'm patching them, I'm updating them. And that's not the responsibility of the developers anymore, right? That's a security operational function to keep all of those components up to date, patched, and making sure that they're not vulnerable. But if the security ops team doesn't know that these components are being used, shockingly enough, they don't know when they're vulnerable. They don't know when they have to be updated. And again, bad things happen in prod when we don't have that process.
And thinking one of the biggest, simplistic attack vectors that are happening that have nothing to do with really developers. Well, maybe it does for developers that just make a mistake. Is the concept of typo swatting. It's like just messing with the name of a file to somebody that's under pressure for a deadline to get out there, and they're like, I need this package, and this one letter's off, or one dot is off, or version is off, and they're like, oh, I need that. Let's go, speed. Gotta hit the deadline. And it's that different lens of risk, just trying to confuse people to get something in there in any way, shape, and form. It's not really that technically complicated. It's just hoping that human error comes into the equation.
So, Mike, to Matt's point, are the bad guys laughing at us because they set up a little typo squatting thing? They phish somebody's credentials, and they're distributing malware everywhere, and the bar is not all that high. So from their perspective, are they kind of just watching and listening to what we're doing and kind of chuckling to themselves?
Well, there's always going to be some part of that, and half the time they're listening on what we're actually doing, but that's a different issue. I think the reality is what we have to do is stop really focusing on, what everybody else is doing out there and all of the noise, and make sure that we've got the right underlying processes internally to position the organization for application security success. If you did none noise, no amount of new vulnerabilities, no log4js, no, kind of struts issue, all of that just becomes another fire drill on the list of unending fire drills unless you have a solid structure and process and accountability to ensure that you can handle a lot of these things. So yes, I want to react. I know that these guys, laugh. I want to have the last laugh on them. But if I'm not in a position to do that, again, I'm just, flogging from one thing to another, playing constant whack-a-mole. And that really is no way to go through your day.
Matt, you cannot walk down the street these days without somebody telling you about this great new AI thing that they've created. So can AI save us from ourselves as it applies to software supply chain security? Can we start using better tools, and what might that look like? Or is it just hype and noise?
It's both. So again, just like, all these new terms out there that people gravitate to, we talked about shift left, which is a phrase that people use ad nauseum, software supply chain security, SBOM. What are all these things? AI is in line with all of that. And I've seen AI working correctly and implemented correctly is so powerful, so amazing. But people are having FOMO with AI. They realize that AI is actually a very difficult thing to do correctly. And they say they do AI, but truly on the back end, they don't. It's not truly AI. It's something else. It's a manual intervention that's using a couple cobbled together tools. I think that AI has unbelievable opportunity to change the way we process just the amount of alerts and vulnerabilities in the software supply chain and application security space. But again, I'd always do the sniff test on when somebody says they're doing AI. How are they doing AI? Is this truly artificial intelligence that's actually working to actually solve a problem? Or is it somebody that's basically doing a little smoke and mirrors? Or if you saw the movie Up, the squirrel, they're like, hey, we do AI. Squirrel, so what are we working on here? Just AI is important, but make sure that it's really AI and not something masquerading as AI.
You mean to say that an if this, then that statement is not AI? I'm shocked.
Well, if the machine is building it, maybe it is AI. I don't know. If we got it pumped, falling out of the bottom end of Copilot, then maybe that is AI. I don't know how to define it anymore.
Because I mean, it's like if you're not doing machine learning or AI, your product sucks these days.
Yeah.
I mean,
we have a question from the audience. Somebody wants to know if their end user license agreement policies are dictating giving away privilege access to various functions? And, have we not thought through what we're actually allowing people to do and not do in these processes? I mean, where does that license agreement come into question? Matt, any thoughts?
It's kind of like when you download a new app on your phone or open up a web page. Now it's asking you for these permissions, and people may be pouring things in there that you don't really agree with, but you just click through just to get through it. I'm just not sure if they're actually defensible. There's so much in there, and if something happens, then you're going to actually have a conversation. But I look at software supply chain coming in there as well with third-party risk management. I'm a company trying to buy software in addition to all the license agreements and all that. How do you know what you're getting is secure? Or your M&A, buying a company, I want to get this, buy this piece of software or application for the revenue it generates or the functionality it gives me. But how do I know that there are not issues within that from a supply chain risk? So doing that vetting process, whether it's the user agreement, whether it's a package you're using or a piece of software using for your own company or something you're buying, you have to actually understand that and actually read the thing. It's annoying, it really is. But why would an application that I'm using to, I don't know, do something very mundane, like, I don't know, read a sporting article, need access to my camera, my microphone, and all this type of stuff? But people click through that all the time, just blatantly, blindly, just for getting access and getting it done quicker. Mike, do you agree with that?
I do. I just think, here's the problem, Matt. One, I've spent a good part of the last 15 years looking at contracts in some way, shape, or form. I am not a lawyer. You don't want me making legal decisions for you. I can sort of interpret and understand what a lot of these things mean, but after 30 pages, I'm human and I just shut down and I don't really understand, what's there. And the other thing is, depending on the size of the contract, you have limited ability to really tune the EULA, right? So what you have to have is a relationship with the business folks to say, this isn't going to work for the following reasons. And honestly, if it's a $1,000 a month thing, you got a business decision to make. Here are the risks. This is what I think is problematic with the EULA. Accept it, don't accept it. That's a business decision on that front. That's a risk management decision on that front, because for $1,000 a month, you're not going to get, kind of lawyers on both sides to, fundamentally change, kind of what the contract looks like. If I'm cutting a 7-figure deal for something, yeah. Right. I've got external counsel looking at that. I've got a whole mess of other folks looking at it, and I'm making sure that I understand what these terms are and that I'm comfortable with it. So it gets back to different gradations of, kind of the influence you have. But in all cases, and let me repeat that, in all cases, security can and should come back with a set of, kind of issues that they have with, kind of that specific licensing agreement. And it's incumbent upon the business to, decide whether they're willing to take the risk or not. And by the way, document all that stuff so that when something does go down and you're thrown off the bus, you can at least be holding the paper as you're rolling on the side of the road going, but I told you about this, but I told you about this.
All right. Feels good. We have another question, Matt, for you. Is there a way to scan software delivery pipelines for gaps and leaks and spot vulnerable misconfigurations? And I'll roll in the next question. And then can I extend that to third-party risks and vendors as well? So I guess somebody wants to know, what is the current state of the art?
So think about the state of the art. Again, I always say it's like this process of development is a V, but it comes to a choke point. What is that choke point? That piece of software that is finally compiled. And every, static analysis or SAST or software composition analysis or scanning APIs, all that is very important, or the tooling. But again, you want to work smart, not busy. So thinking about the thing that you're actually creating through this whole complicated process with tons of tools, tons of technologies, tons of people and their responsibility, you're creating a deliverable, a package, whether that's a web application, a mobile application, a piece of for-sale software. And if you want to know everything about something, go to the source, that compiled package. And that's the thing that I think people want to, do 1,000 things. But if you look at that, at least you have a record of the thing that people are going to either purchase, upgrade to, or use in a, a web or a mobile environment. So if you are concerned about the unknown, questionable behaviors, all those type of things, you have to actually look at the compiled package, because that is the gold standard, gold disk copy of what people are going to use. And more importantly, what hackers are trying to actually compromise, because they're the ones accessing that.
Mike, are we a little too obsessed with source code and not enough on the binaries, to Matt's point?
So, there are two aspects of that, right? So if it's components that I am actually building into and integrating into my application, then yes, I have to worry about source code. I have to worry about binaries. I don't think it's one or the other, right? I mean, I think you got to, kind of scan and do what you can with what you have access to. I don't want to forget about the fact that a lot of these modern applications, either via APIs or leveraging and integrating other SaaS type services in there, we don't have access to source code on those. We don't have access to kind of binaries in that kind of environment, and that's as much a part of modern software architecture as a lot of these open source components that we're using in a lot of cases. So that's when diligence up front comes into play. I've got to have my questionnaires, and that really hits on the third party, risk management piece of that, which is I've got to go through some aspect of diligence to understand what access do these folks have to my application, to my critical data, how are they using it, what does their security program look like, am I comfortable, with these folks when I talk to them, do they pass the sniff test that they actually give a rat's ass about security on that front. So I do think we do what we can with what we have if it's stuff we're building into our environment, but you have to have, again, a process to establish and define and do, diligence on a lot of these other services, right? And API accessible resources that we're, again, increasingly calling from within our applications.
Yeah, Mike, I totally agree. The thing that I always say is, it's applications are not an island. They're interconnected for, sharing of data, sharing of functionality. But the one thing that is in there are the keys, which are, one of the biggest topics that is going around now is secrets. And we haven't even touched on this, and we've been talking for 51 minutes. So you can kind of, see where this is going in terms of its sprawl by just looking at the secrets that are part of that package to basically open up, be the key to the lock to access that functionality, that data, what have you. And, again, we could have a whole a complete additional webinar about secrets and proper usage and, the whole process of rotating secrets. I mean, we could talk forever about that.
Yeah. Let's just say the old, list underneath your keyboard, not so good, right? When you're talking about, kind of secrets that you have integrated. So we've just got a handful of best practices, right? Kind of key vaults are a great thing. And whether it's Vault, right? The open source thing, whether it's, kind of a key vault or secrets manager or what have you on the cloud platform that you're using, having different secrets management environments for each application in each environment, right? Non-prod and prod gives you that isolation that you want to, so that if one of your repositories or your secrets environment gets compromised, you don't lose all of the secrets to everything, right? So isolation continues to be an important aspect of that. And as Matt said, that's really barely even scratching the surface, but, suffice it to say, if you don't have a whole mess of, key vaults in place, you're doing it wrong. Because that's going to be the place that you get hurt probably the fastest.
Matt, do you think we have a generational issue? Because the people who've been developing code the longest are the ones most likely to leave secrets in text in an app, right? Because that's the way they always used to do things for 20, 30 years. And, is it going to be possible to teach everybody, a new trick, as it were?
I don't think that's the problem. I think we have a complexity problem. Again, software is moving so fast and being changed, and it really is. I've been saying this for a long time. Software is a Frankenstein monster. It's something that has existed and evolved over time. Rarely do people start developing software from scratch. Yes, it does happen. I'm not saying that doesn't happen, but you're using Microsoft Windows, or you're using, Salesforce, or you're using all these different SaaS platforms or desktop operating systems. They're evolving over time. There's older code in there, there's newer code in there, there's new capabilities. The speed and the complexity is creating opportunity, because everyone has a social media mind. They want the next release out, the next functionality out as soon as possible, which makes it really, really hard to know everything about that entity and how it's evolved. A lot of times people, use a SaaS scanner to scan and say, you have all this dead code, why don't you pull it out? They're like, don't touch the dead code. We don't know what it does and what it may break. So It looks like dead code, but it may break something, because the last time we pulled dead code out, we crashed the system. And I think that's the problem, is people just don't know where things live. Hard-coded passwords, secrets that are in clear text that are not encrypted, all those things are based on the complexity and the speed of the process.
All right, everybody, we have a bunch of handouts on secrets management in the handout section that our folks at Reversing Labs were kind enough to share. So by all means, check that out. Mike, what's your best advice to folks? What's that one thing that you wish everybody would just kind of like focus on to get started?
So if you sit in a security role within an organization and you like to drink beer, take out the developers for a beer, right? And if you're a developer and you like beer, when the security person calls and says, let's grab a beer, say yes. Right? Because I found that beer is one of the best ways to help build relationships outside of all that awkward stuff where it's like, I don't know who you are. I don't really know, kind of what you're about. And I kid a little bit, right? I don't want anybody abusing anything, to that degree. But the fact is we have to get out of our little cloistered cubes in that environment and start building these relationships, because I do think that to ultimately be successful in managing software supply chain security or just application security in general, it is going to take all of us sitting by the campfire with our marshmallows singing Kumbaya, because if we're not all on the same page and we're not all working together, it just can't work.
Matt, what do you think? Pizza and beer solves all the problems in the world?
Well, absolutely. I was going to say, Mike, make sure you bring pizza, because it'd be irresponsible just to bring the beer. You need to offset a little bit of food in with the beers.
That's right.
Yeah, absolutely. I mean, I think we're at a kind of a crossroads in terms of, identifying the risk in applications and doing it in a way that's actually a complete chain, as I like to say. So supply chain, where I think we've become very, very comfortable in looking at specific pods or links of the chain. And I think we got to take a step up and look at everything from a holistic view. The process of building the software, which is the DevOps tooling. I think we need to look at everything and not just focus on the open source code or the APIs. It's very important to look at those things, but you need to have that final exam of everything. Look at the complete process and the product of that process, because if, again, you're not looking at somebody could insert something right before that build is happening. It's happened before in software supply chain hacks where a build environment's process is compromised. Stop looking at just the building blocks or the links of the chain. Look at the whole thing, is my opinion.
All right. Last quick question, Mike. We got somebody who's saying, hey, the way we build software today, very little of it is actually built from the ground up. It's all in these components. So maybe we need to figure out how to apply policies at the point where those components are being consumed. We got 2 minutes.
Or considered, right? So actually, kind of the earlier that some level of security representation can appear within the architectural process, within the design process, we can avoid a lot of heartburn. Right, just by understanding it, a security architect can look at something pretty quickly and go, yeah, no, right? Whereas if it's already built or, certainly in flight, you have limited ability. So the earlier we can get those discussions happening, the less likely we're going to use faulty components and just poor design practices and principles. So getting out ahead of that, I think, will really help.
All right, an ounce of prevention is still worth the proverbial pound of cure. Hey, Cody, I'm going to hand it back to you, but Matt and Mike, thank you for sharing your knowledge and insights as always.
Thank you.
You bet.
All right. Well, Matt, Mike, and Mike, thank you all so much for joining me today. It was nice having the 3 M's so it's easy to remember. I'd like to remind everyone that our session today was recorded. So should you want to rewatch, or of course, if you'd like to share this, you will be receiving a link to access the recording on demand. It will be in your email, but it will also be living on the Security Boulevard website at securityboulevard.com/webinars. The 4 winners of our $25 Amazon gift card giveaway are Erica D, Omo F, Anurag A, and Gail E. So to our 4 winners, congratulations. Keep an eye on your inbox to claim that gift card. It should make its way to your inbox in about the next 48 hours. But if you don't happen to see it, please do check your spam folder just in case. I'd like to thank Security Boulevard for hosting our program today. And to everyone who's been with us for the past hour, thank you so much for tuning in. We really appreciate your time, and we really want to hear your feedback. As soon as we close out, there will be some questions that pop up, so feel free to let us know what you thought about our program, or maybe what you'd like to see on an upcoming program. Regardless, we do hope to see everyone at a future Techstrong learning experience. Have a great rest of your day. And again, Matt, Mike, thank you.